You know each and every way that we're doing it. So let's just go straight down the list. I'm going to do number 2, and then I'm going to let you do number 1, because 1's a little bit easier than 2. And then we're going to flip it over. I'm going to do 4 and let you do 3. Okay? And then I'm going to do 1. Okay? And then 7. It looks like 5 might be a little bit different than those two. So yeah, let's do those. 1, 5, and 7. Okay, on the back, and then I'll let you do the rest. Okay, so first thing we're going to do is find x-intercepts. How do we find x-intercepts given an equation? This is important, so you need to know how to do this. How do you find x-intercepts given an equation? X-intercepts is when x is equal to what? Not x is equal to 0. It should be what? It's crossing the x-axis. Y is equal to what? 0. Okay? So when y equals 0, put this in your notes. Yeah, take out some notes. This is going to be important. Because like I said, we're going to have a test on this, and then you're going to be like, wait, how do we do that? So let y or f of x equal 0. Okay, to find x-intercepts. What are x-intercepts? They're the points that it crosses the what? X-axis. So I'm going to say 0 equals x squared minus, oh wait, I'm doing number 2, huh? My bad. Negative x squared, sorry, plus 5x minus 4. Okay, so far so good. All right. Now, I want to solve this for x. Now, because I have an x squared and an x, I'm going to have to factor, right? So let's first factor out the negative. You never want the first term to be negative when factoring. That's something else you might want to write in your notes. Always factor out a negative if the square is negative. Okay? You don't want the negative in front of the square, or it doesn't factor right. So I'm going to factor out the negative. All that means is I'm dividing each and everything by a negative 1. In other words, every sign's going to what? Change. Yep. So instead of negative x squared, it'll be what? Positive x squared. Instead of plus 5x, it'll be negative 5x. Instead of minus 4, it'll be plus 4. Now, I don't know how you learn to factor, because I didn't teach all of you, but the ones I did teach, you'll know how to factor this. You simply read it backwards. You ask yourself 2 questions. What are the 2 questions you ask yourself? What multiplies to be 4 and adds to be 5. Don't worry so much about the negative. Just read it backwards, the last 2, okay? What multiplies to be 4 and adds to be 5. Pretty easy if you think of it. What will it be?
1 and 4.
1 and 4. Everybody agree? Notice I don't put in my signs. I just put the 1 and 4 at the last, the x and x at the first. The reason I'm doing that is x times x would give you x squared. 1 times 4 would give you 4. See how you're getting the first and the last terms? Okay, but the middle term, I got to think about the signs. If it's a sum, meaning the last term is a sum, a plus, then the signs will be the same as the middle. So they'll both be what? Negative, negative. Okay? This still equals 0. Okay? What can I do with this negative 1? Can I divide it out? Yeah, all it is multiplying, so I can divide out negative 1. What's 0 divided by negative 1? 0. And then I have to set each factor equal to 0. X minus 1 could equal 0, or 0 could equal x minus what? 4. Now I just solved both of those. X will be what? 1 or 4. Now I can graph those on my graph. So I'm going to put my graph out here to the side. Okay, what should I mark on my graph? 4 and 1. So there is 4, 0, and what? 1, 0. And I should put those for my x what? Intercepts on the left. So on the left, write x-intercepts. What am I going to write? 1 and 4, but it's smarter to write, even as a point, 1, 0, and 4, 0. Okay? Now, y-intercepts. What are y-intercepts? It's where it crosses the what? y-axis, when will it cross the y-axis of an equation? When x is what? X is what? 0. That's when it's crossing the y-axis. So if x is 0, all I got to do is plug that in. So I'm going to say y equals, and then I'm putting in zeros for x. 0, I guess you can say negative 0, plus 0, putting in a 0 for that x, minus 4. What am I going to get? Negative 4, right? So I want to go to negative 4 on the what axis? Y. So down 1, 2, 3, 4. Okay, so this point is 0, negative 4. Okay, and again, that's what I probably want to put for my y-intercept. 0, negative what? 4. How did I find it? Simply plug in 0 for x. That's different than setting it equal to 0, which is what we did to find the x-intercepts. Do you understand the difference? To find the x-intercepts, you set it equal to 0. To find the y-intercept, you plug in 0. Do you understand the difference? That's super important. Okay, let's try the next one. Maximum or minimum point. This is actually called the vertex. You might want to write that out to the side. Now there's a couple ways to find the vertex. Okay, you could do negative b over 2a. Some of you remember that from the equation. Okay, I could do negative b over 2a. I could also just do the midpoint of my x-intercepts. So that's what I'm going to do. What's the midpoint between 1 and 4? What's halfway between 1 and 4? 2 and what? 2.5. 2.5. Everybody agree with that? Now, how did I get that? I simply added 1 and 4 and divided by what? 2. So 1 plus 4 is? 5 divided by 2 is? 2.5. Everybody got it? Now, you can also just think about it by looking on the graph. Hey, I go this way 1, I go that way 1, and then halfway between is 2.5. If you did it that way, that's fine. I don't care which way you do it. But you use the what? The midpoint between the x-intercepts. Now, the only time this won't work is if it doesn't cross the what? X-axis. If that's the case, I'm going to show you another way to do it, which is start with this equation and do opposite of b, negative 5, over 2a. So negative b over 2a gives you the x-coordinate. Okay? Negative b, so it's in, so think about the equation ax squared plus bx plus c. Okay, that's what we call standard form of an equation. Okay, so this is the standard form. To find the x-coordinate, you can do negative b over 2a. This is stuff you learned last year, but you might have forgot. I understand if you did. So this is negative b over 2a. Okay, this will find the x-coordinate of the vertex. Okay, so it's negative 5. How did I get negative 5? Think about this equation. Opposite of b. Instead of plus 5, I wrote what? Negative 5. And then over 2, that comes from that 2, times negative 1. That's the a value. So what's 2 times negative 1? Negative 2. Negative 5 over negative 2. A negative over negative is a, and I end up with 2.5. I'll end up with the same answer. Okay? So either way, to find the x-coordinate, you find the midpoint between the two x-intercepts, or you use that equation, negative b over 2a. When won't I be able to do this with the x-intercepts? When won't I be able to do the midpoint? If it doesn't cross the x-axis. Are there graphs that don't cross the x-axis? Yeah, I could have something like this. Is that ever going to cross the x-axis? No. I'm not really worried about that interfering with the graph I have. But if it doesn't, then I'm going to have to use this negative b over 2a thing. Everybody got it? Okay. All right. So that's the x-coordinate. How do I find the y-coordinate? Plug it in. Okay, so I'm going to plug in 2.5. Does it matter where I plug it in at? Does it matter where I plug it in at? Doesn't matter. I'm going to plug it in right here because I think this is easier. Okay, so I'm going to put in negative 1 times 2.5 minus 1 and 2.5 minus 4. Could you plug it in here and square it out? Yeah, you can plug it in either place. I just don't like squaring things, so I get confused when I do that. So I'm just going to do it here. If I had a calculator, I might just plug it in right there in the original. Just put in 2.5 squared. Just remember that you're going to make it negative. A lot of kids think that they're taking a negative squared. You're not. You're taking 2.5 squared and then making it what? Negative. You with me on that? A lot of kids mess that up. If I do it in this equation, nobody messes up the signs. That's why I do that. Okay? So I'm going to put it in here. 2.5 minus 1 is 1.5. 2.5 minus 4 is negative 1.5. And then I got this negative out front. So a negative times a positive times a negative is a positive. I know that. It's 1.5 times 1.5. Somebody do that on your calculator. 2.25. 2.25. And all that is 1.5 times 1.5. 2.25 is the y coordinate. Okay? Where's that point then on my graph? Where's this point? Is it right or left?
Right.
Right. How many right? 2.5 right. How many up or down? Up 2.25. So I'm going to go right. Don't mark the point 2.5. Okay, a lot of kids think, oh, I should mark the point 2.5. Don't do that. Just go over to 2.5 and then up to what? 2.25, which is just a little bit above the 2. Okay? And then I'm going to tell everybody, hey, this is my point, 2.5, 2.25. That's my vertex. What does that mean? That's where the graph turns and goes back down, right? It's my highest point. If it's a high point, is it a max or a min?
Max.
Max. So I'm going to say this vertex is a max. Okay? And my max value, my max point is 2.5, 2.25. Okay. Now, let's, by the way, if I am at 0, 4, and the midpoint is 2.5, I've gone 2.5 to the left. Does everybody see that? To get to 0. Does everybody see that? If I'm at 2.5, and I want to get to 0, how far do I go? 2.5 left. What if I went 2.5 right? Where would that be? 5. If I'm at 5, where will I be on the y-axis? Because this is a parabola, it's got to be symmetrical. So where will I be at 5? What do you think, Sid?
I don't think it crosses the line.
So if I go over here to 5, it should match where it crosses the y. Okay? So I should be at 5, negative what? 5, negative 4. Okay? If you think about it, if you folded your paper, right, along an axis, a point here would be the same distance as a point over here. A point down here would be the same point over here. If this was the y-axis, you with me? Or if this was the axis of symmetry, I should say. So down through any parabola is an axis of symmetry, and these points should fold upon each other. Is this dotted line part of the graph, really? No. It just helps me kind of think about the graph. Helps me think, hey, that's going to go down through there, and that's going to go down through there. Okay, that's my graph. You don't need the dotted line. Okay. All right. Now, we've got the maximum, minimum points, we've got the x-intercepts, we've got the y-intercepts, and we have what we call a symmetrical point to the y-intercept. That's always nice to have. It gives you a connection point to kind of graph. So I have the symmetrical point to the y-intercept. Okay, those are some key points you want on every graph. At that point, you can tell me all the other stuff. What does the domain mean? And if you don't know what the meaning of these words are, you need to write these in your notes. What does domain mean? Anybody know? All what numbers? All the numbers that x could be. In this case, Isaac, it's what? In this case, it can be any real number, because can x keep going out here forever? Yeah, I could go out to 100. I would just be down at like negative a billion, right? I could go out here to negative 100, but then it would be down at negative a billion, right? But x can be any value you want. So the domain is all reals. Here's how you'd write that.
I remember that.
The set of all x's such that x is an element of the real numbers. That's how you write it.
What if
Okay?
we can't just write the weird R thing? We have to
The-
write it out that.
You should write it this way, and I'm going to tell you why. Because when you get to college, the very first class you have is going to have you write what they call set notation. So I want you to get used to writing it. It's not very hard. Think about what it says. It's the set of all the x's, meaning it can be any of the x's that fit this criteria. The criteria it has to fit is that x has to be a what number? Real number, an element of the reals. So that's how it says that, an element of the reals. Okay, let's think about range. Can y be every single y value on that graph? No. Y is never going to get bigger than what? 2.25, right? So this time I'm going to say this is domain, because x can be anything, right and left. But up and down, it can't go past that point. So I'm going to say the range is limited, okay? I'm going to say the range is a set of all y's such that, that's all that says. The set of all y's such that y has to be what compared to 2.25 then? Less than or equal to 2.25. Close the set. That's the what? Range. Again, I want you to get used to using this set notation. Okay? I want you to get used to using the set notation for domain and range.
Why do you use 2.25?
Why did I use 2.25? Very good question. Why am I using 2.25, you guys? That's the vertex highest y value I'll ever get on this graph.
And the 2.25
2.25 is the y value of the vertex. Can I go any higher than that? No, because up here, the graph's going to turn and go back down. It's never going to go higher than that. So that's why this is a maximum point. That's why we call it a max. And that's why our range is limited to never go above what? 2.25. What if it opened up? Then it would be a minimum value, and I would say y would have to be what? Greater than or equal to it. You see what I'm saying? So it just depends on whether it's a high point or a what? Low point. Everybody understand that now? Okay. All right, let's try the next one. I'm always. Let's go to increasing, decreasing, positive, negative. Is that okay? I'm not erasing the whole thing. I'm just erasing this part so that I can write it over here. This part we did a while ago. That I'm going to leave for domain and range. Okay, so let's talk about increasing and decreasing. Okay, what this is talking about is always reading left to right. And you might want to put this in your notes. Increasing and decreasing always reads left to right. Okay, left to right. And we're thinking about the y-axis. What's happening to the graph compared to the y-axis? So as I go from left to right, until I hit 2.5, what's happening to the graph? It's increasing. Once I hit 2.5, what's happening to the graph? Decreasing. So that's what I want to put. So on the increasing, I'm going to say when when x is less than or equal to what? Now I'm looking at the x values, not the y values. That's why what's her name? Alejandra? No, what's her name? Alex? Allie. What Allie said was super important because when we were talking range, we're looking at y values. When we're talking increasing, decreasing, we're looking at what? X values. Okay? So I'm thinking, all right, it's going up on the y for what x values? Well, from everything to the left until I hit what? 2.5. So for every value that x is less than or equal to what? 2.5, the graph is what? Increasing. Okay? Now some people and some teachers will show you this, and it's still true. And I might do this just to show you so that you don't get confused later on. What does that mean? From negative infinity, starting at negative infinity, until I hit what? 2.5, the graph is what? Increasing. Okay, increasing. So this is increasing. How come it was increasing? It was going what? It was going up. Okay? If it would have been doing the opposite, going down, then this would have been the interval that it was what? Not increasing, but what? Decreasing. In fact, our next interval is going to be the decreasing. When is it going down? Well, again, read left to right. Left to right is key. From what? 2.5 until I hit positive infinity, right? So it's decreasing from 2.5, x has to be greater than or equal to 2.5, and then it has to be less than or equal to what? Infinity. Because it's going to go as far to the right as you can. It's consistently going to be what? Decreasing. Everybody got it? So that's increasing, decreasing. Any questions on that? You're comparing the x values with when the y values are going up or down. Okay, reading left to what? Right. Right, that's super important. Okay, let's talk about positive and negative. Positive and negative just compares the graph to the x-axis. You might want to write that in your notes. Positive and negative compares the graph to the y values with respect to the x-axis. So the y values below the x-axis are what? The y values below the x-axis are negative, and the y values above the x-axis are positive. So that's where we get the idea of positive and negative. So what's the interval? What's the interval of the graph that it will be positive? From what to what? I'm really looking at the x what? Intercepts. Yeah, the x values, the x intercepts. What are the x intercepts at again? 1 and what? 4. It's above it between what? 1 and 4. And again, between is kind of written this way. So I say, okay, when x is greater than or equal to what? Well, not equal to, I guess just greater than, huh? Because if it's equal to, it's 0. Is 0 positive? No. So I'm just going to say greater than, I guess. When x is greater than 1 and less than what? 4, it's positive. Okay? If this was opening the opposite way, it would be negative right there between 1 and 4. Are you with me on that? But because it's opening down, that's where it's positive. Okay? Where is it negative? Where are all the y values negative? Anywhere below there, so negative. Again, I like to read left to what? Right. Left to right. So from negative what? Infinity. From negative infinity until we hit what?
0.
Nope.
1.
1, right? Till we hit 1, it's negative. And it's also negative where else? Read left to right. From what? 4. From 4. Until I hit what? Positive infinity. It's always going to be negative. It's always going to keep going what? Down. Okay? So there's positive and negative. Okay? That's all you got to do on each one. Okay? Positive and negative on each one. All right, flip it over. Let's do one more of these just to make sure you got the hang of it. Okay? We're going to do number 4 together. Now this one, I'm not going to give you the answers as quickly. I want you to think of it, okay? Because we just did one like this. So what's the first thing I should do to find the x-intercepts? Say that again? I'm going to factor out a negative, but I'm going to set it equal to the f of x is going to be what? Instead of f of x? 0. Okay, so write that first. And factor out the negative. You can do two things at once. So both what Jack said and what Destiny said are right. I'm going to say 0, okay, is equal to, and now I'm factoring out the negative, negative x squared plus 6x plus 9, right? So that's both what Jack said and what Destiny said. We're doing both those things, same time. Setting it equal to 0, I'm factoring out the negative. Now I can read it what? Backwards. What multiplies to be 9 and adds to be 6, Jesse? Put your phone away.
Well, 3, 2, so...
What multiplies to be 9 adds to be 6.
3 and 3.
3 and 3. So I'm putting x and x. 3 and 3. I'm going to divide by a negative 1 just to get rid of it. That's still going to be 0. Okay, what are my signs on my 3 and 3? It's a sum, so the signs are the same. They're both positive. Sum, same, both positive. Okay, set each one equal to 0. What's x going to be? Negative 3. And this is also going to be x as what? Now I'm going to tell you something. We have what? We talked about this before. Yeah, there you go. Say it again, Willie. Or was it Willie? It wasn't Willie. It was, what's your name? What? Addie?
Yeah.
Addie? Okay, Addie, it's what? Duplicity, which means it's going to be the vertex. Yeah, this is kind of interesting because we're actually going to have the vertex here. Where will the vertex be then? At x is what? -3. So this will actually be the vertex. So boom, that's the vertex. All we got to decide is the graph going to open up or down? Well, because of the negative in front, it has to open what? Down. So we know it's going to open down from there. Now, by the way, in the original equation, remember we had -x² minus 6x minus 9. This will help us because what is the y-intercept going to be? -9. How did we get -9? Put in 0 for what?
All the x's.
All the x's, and you're going to get just the constant that's at the end, -9. So I'm going to come down here to -9. Okay, this is the tricky question. Caden, do you think you can handle this? 6, 7, 8, 9. So this is 0, -9. Okay? And this one is -3, 0. Tell me where I'm going to be on the graph at -6. How come?
Because it's mirrored.
It's mirrored. It's symmetrical. Notice I've gone 3 to the right to get to 0. Everybody see that? So if I go 3 to the left, should I be at the same point? Yes. So down here at -6, -9, right? Over 3 from there, over 3 from here, mirrored points. -6, comma, -9. Okay, now can I kind of flip a graph thing so that I kind of know what it looks like? Yeah. Just connect it. Boom, there's my graph. So I got my graph done. Okay. Now this one was interesting. Did I really even have to worry about finding the maximum, minimum, whatever? No, because it happened to be duplicity, right? Like Addie said. What if it wasn't though? What if I didn't know? Well, I would still do the midpoint. Oh wait, there is no midpoint. The midpoint is what? -3. So the midpoint of -3 and -3 is still -3. So that's one way to think of it. What if I had done -b over a? So think about this equation. -b over 2a. Would it still work? What's the opposite of -6? 6. You with me? Over 2a. 2 times -1. That's 6 over -2, which is negative what? 3. You put in -3, and what are you going to get? Plug it in. What's -3 squared?
Well, now it's going to be positive.
-3 squared will be a positive, so it'll be what? +9. And then -3 times 6 is -18. What's 9 plus 9 minus 18? 0. So I end up at -3, 0. Okay? So that's how you would find that, even if you did -b over 2a. It still works. Okay, so that's our maximum or minimum. By the way, is it a max or a min?
Max.
It's a max because the graph's opening what?
Turning it down.
Nope, opening down. 3 and 1 that I'm going to have you do will both open what?
Down.
Nope. Look at 3 and 1. The x squared is both on both of those is what?
Positive.
Positive. So those are going to open
Up.
up. Okay, 3 and 1 are going to open up. Okay, this one's going to open down though, so I'm all right with that. Now what am I going to say about it? What is next? Domain. What's the domain? Set of all x's such that x is all what? Reals, right? All reals again, because x can be any value. Okay? How about the range? What's the highest y value it'll ever be? 0. So y has got to be what? Set of all y such that y is less than or equal to what? 0. That's the highest y value I'll ever hit is 0. Okay? So that's the range. What is the increasing? What's the interval that it's increasing? From -infinity, right? From -infinity, x has got to be greater than -infinity until it hits what?
0.
Till x hits,
-0.
x hits what? -3. So from negative, so I'm going to write it this way. From -infinity, x has got to be greater than or equal to that, and it's got to be less than -3. That is where it is what? increasing. Where is it decreasing? From negative 3 until what? To positive infinity. Right? Because this is where it's decreasing. Going what? Down. All I'm reading is left to what? Right. That's the key. Okay, so there's decreasing. How about positive and negative? Is it ever positive? Never positive. How come? It never goes above 0. So it's never positive. It's negative where? Everywhere but what? Everywhere but negative what? 3. That's the only time. So this is the way I write that. I just like to write it this way. The set of all x's, this is for negative, such that x is an element of the reals. That means all reals are negative, except x cannot equal negative what? 3. Because at that point it's 0. Okay? So this is all reals. All of the whole graph is negative, except one point. What point is it? Negative 3, at which point it is what? 0. You see what I'm saying? That's what that says. And that's why I like using set notation, because I can use it in a lot of different places. And it makes it easier to actually write out. Okay, flip over your page. Okay, and let's do 1, 5, and 7. Okay, so look at 1. I'm looking for the points that it crosses the x-axis. Those are the roots. Okay, the word roots is the points that crosses the x-axis. Matthew, where does it cross the x-axis? On number 1. It's kind of hard to tell, but where is it crossing the x-axis? Just at 0. Okay, so the only root for the x-axis, the only point across the x-axis on number 1 is at what? 0, 0. So my root is 0. Okay, what's the y-intercept? Well, obviously that's also what? 0. So I'm just going straight down the list. Okay, how about the maximum value? The maximum value is positive infinity, right? Because can I keep going up on those? Yeah, so positive infinity. What's my minimum value? Negative infinity. I can go as far as I want low on it. Where's the domain? Can an x be every number? No, there's a couple numbers it can't be. Tell me what x can't be. Where will it never touch? It approaches but never touches.
4.
Negative 4 and positive what? 4. Okay, so how do I write that? So for domain, I'm going to write the set of all x's such that x is an element of the reals, and then I just put in the except parts. Except x can't equal what? Negative 4 or what?
4.
4.